Hey, so in this lecture I want to talk about callbacks or callback functions. Now I've already talked about these callables, function pointers, function objects, including those in the functional file, and then we also have lambda expressions. Moving on to callbacks, we've actually already seen callbacks in action. A callback is a callable that is passed as an argument to a function, which may invoke. So in the body of the function we may call or call back the callable argument. This allows us to write generic reusable functions where the logic is customizable depending on the callable that we pass in. Right, as we've seen in previous examples, we can have some function that performs a modification on the elements in the array. It can square all the elements, for example. The function will basically have a callback formal parameter, and by using a template or the standard function, which we'll discuss later, we can write even more generalized functions where we can pass in lambdas or functors or function pointers. And with this, we can have really flexible, reusable functions. We've actually seen examples of callbacks in previous lectures. So for example, have this display function, and we will use that as a callback function in this lecture. In the print scores function, again, this is going to take in an array, the array size. Then for the third parameter, we have a function pointer because we want to pass in the display function again. I'll print out the scores are, and then within the for loop, I'm gonna use that callback. So we'll call the callback, and we will pass in the array at that index, and we will display whatever the element is. So this is what we do in the main function. We have that array size again, which we pass in for the size of the array scores, which is an array of integers. I initialize the elements in the array to these values, and then I invoke that print scores function. I pass in the array size, and the function. So that is going to be our callback. And here we go and invoke the callback. Or in other words, we call the callback. So if I build around that, this is the output that we get. We've actually seen other examples of callbacks as well, so we can pass in a functor, and we can also use a lambda for a callback. We will see examples of those in the upcoming subsections. In this example, I have an addition functor. It's going to do the addition, it's going to return the int. Okay, so it takes in two operands, and it's going to return the addition, the result of addition of those two operands. And then I also have an add function, which does the same thing. And then I have this modify elements function. We looked at this before, but this time it's a bit different, because in this instance it's going to perform a binary operation. Previously it performed a unary operation. The first operand is going to be the element in the array so that we pass in, and the second operand is going to be what we pass in as an argument, and that is going to depend on what operation we want to perform. If we want to perform addition, we want to pass in the element, and then also the second operand is going to be what we want to add to each element, or what we want to multiply or subtract, or whatever we want for that second operand. This modify elements function again is going to take in an array. It's going to take in the size of the array. Now I would like to mention that of course you can do a pointer, and then you can pass in a reference to the array as well. That is where you invoke the function. But in this case I prefer to stick with this sort of syntax, because where we invoke the function it's going to be easier for us to see what this expects based on the formal parameter list. Okay, so it also takes in the array size, and then as I mentioned, it's going to take in the second operand. But this function is a template, so we have type name modifier, and I do modifier, modify p for modify parameter. And with that, the goal is that I want to pass in either a functor or a function pointer or a lambda, and I want that to operate on that. In case we do the callback right here. This is basically the callback parameter, because we are going to pass in the callback right here, and then this is where we actually perform that callback. Later on in the lecture, we'll see how we can remove this template, so we can do this without the template function. That is by using the function object from the functional file. You can also have another type parameter here for the type of array, but in this case, just to keep it simple, we'll stick to integers, so we'll concentrate here on the callback formal parameter instead. We want that to be abstract, so I'll do a template for that. So in this case, we can pass in again a function pointer or a functor. We do not have to specify a function pointer here, or a particular functor or anything like that. We can simply pass in what we want, and the compiler will deduce and define the appropriate function definition. Back in main, this is going to be similar to what we've done before. I have a constant array size. I pass that in here, victory points array. Pass that in right here, and I have 3 elements to initialize the array. Next I do these printouts. I have victory points before modification, so I print those out. Then I go and invoke the modify elements function right here by passing the array victory points, the array size, and then also the second operand. Again, remember the first operand is going to be the element in the array, and then we want to pass in the second operand that we'll use for the particular operation because these are binary operations. So I pass in 5 and I want to add 5 to every element. So in this example, the type that is going to generate is a function pointer because I'm passing in this function. I only have these two examples. You can have multiply or whatever else you want to do. I'm just keeping it concise here. And so I'm doing add. I'm adding 5 to every element, and then I'll go and print those out again. Build and run that, and we can see what we get. Before modification 1, 3, and 5. Following modification we get 6, 8, and 10. So we can see that works fine with the function pointer. Now let's go and try with the addition functor here. I'll actually just copy that. So I'll use the addition functor right here. Build and run, and that'll do the same thing. That works fine. Now of course we can also use a lambda for this, so I'll go and define one. The lambda definition is a bit long, so I have a handle for that, and I'll pass that in. You can do it inline as well. I'll build and run that, and that works fine. And of course now we can go and change that operation to maybe multiply or something like that. Build and run that, and we'll see that works fine. So the point of this is we now have a generalized function, and the operation, modification or callback can be specified whether those are function pointers, functors, or even lambdas. Now what I'll do is I'll go and include the functional header. We can now go and use those as well. Those are functors. Remember, these are templated. My own ones up here are not templated currently, so I have to pass in the type. I'll pass in int. And that works fine. Again, those are the standard functors in the functional file. We can also go and do multiplies or whatever we want to do, those binary operations. We pass in again 5 for the operation. Build and run that, and that will work fine. This again allows us to write a generalized function, which is going to modify every element in the array, and we can pass in whatever operation we want to perform on that, whether it's a function pointer, a functor, or even a lambda. Looking at cppreference.com again, previously I mentioned that we have these functors. That is in the standard namespace. We have plus, minus, and so on, all of these arithmetic operations. Now we actually have this sort of functor. It is a template class called a function, which we can use to wrap our callables. It is a general purpose function wrapper, and instances of the function class template can copy, store, and invoke the callable target. The target is basically what we will assign to the class template by using the assignment operator. Okay, the assignment operator is overloaded to assign the new target, whether that is a lambda or a functor. With that said, we can then use the instance of the function template class to invoke the target because the function call operator is overloaded for that class. Again, we can assign function objects, lambdas, and function pointers. If you think about it for a second, if you use a template, that is going to have certain limitations. So for example, let's say you want to store different callables within a container, such as an array or something like that. We'll talk about different containers in the future. Right, let's say you have some container, and in that you want to store different callables again, such as functors, function pointers, and so on. Well, in that case, we can simply create a container of function objects and then store the different callables within that. That may be a bit of an abstract example. That's not something that you may use, but where function objects really come in handy is with formal parameters, and that can reduce the amount of template functions that you have. Not that template functions are a bad thing, but it really depends on what you want to do. A couple of examples using this third function class. I'll just go and include the functional file. Again, that is where the function is defined. Then I have a few things for us to play with. You have this print number function, which is going to take in any int and print it out. I have the add function. We've seen this before. That is going to return the addition of two integers. And then I have an addition functor, which is going to do the same thing. And then I also have a lambda, which is also going to do the same thing. In this case, actually, it's going to do multiplication. But of course, you can do addition or whatever you want with that. The function class is templated. We have to specify the type, and when we do this, we have to remember that this is a wrapper for a callable. Let's say we want to assign the function print num to this, or in other words, we want to make that the target to invoke. What does the print function return? It returns void. And the type for the formal parameter, or in other words, what it takes in, is going to be, in this case, a constant integer. Now we can do the assignment on a different line, but I'm just saving space here, so I'll do it on the same line. I'm assigning the printNum function to this. PrintNum is a function that is a callable, and we need to make sure that the types match. Now we can use the name of the instance, in this case display, to invoke the target, in this case printNum. Okay, we pass in 55, so that should display 55, and I'll build and run that. And that is what we get. That is it for the first example. The next example will focus on these right here. So I'll just go and remove the printNum. If we look at this, the add function is going to return an int, and it has as formal parameters. The types of those is going to be constant. The same thing for the overloaded function call operator in the addition functor. It returns int, and for the formal parameter we have two constant integers. And then also for the lambda, that is going to return int because it takes int, it does the multiplication or the addition of two integers. Okay, it's going to return int, and the parameters are going to be the same again. So let's just go and instantiate a function. This will return int. Okay, instantiate the function. Now it's currently empty. We have to make sure to assign the target. This is going to return that result. This is going to use the overloaded function call operator for the function template class. And with that we will invoke or call the target, which in this case is this add. So I pass into integers. It should add those up, return the result based on that is what we get with the function definition, right? So I print that out, build a run, and that is what we get 5. But now we can do the same thing for the addition functor, so we can assign that. Build a run, and you can see that works fine as well. And also for the lambda, but in this case we are going to do multiplication. Build a run again, and now we can see we do multiplication. So of course where the function template class comes in handy is to abstract away the particular callable, kind of in the same way that you can do with a template. And in that way, in some cases you can avoid using template functions, as I will demonstrate in an upcoming example. But with this example we can see that we can assign, as long as the type matches, we can assign a lambda or a functor or even a function pointer to the function object. Back in this example I make sure to include the functional file, and then I can remove this line right here. Modify elements is no longer a template. Then I'll use the standard function, and for the type we want int. And I'll keep it to modify. You can call it modify or whatever you want. Just to make this easier to read, because we have many parameters here, I'll just press enter right here. So this is what we have. We have the standard function with this type, and it's called modify, so it's the modify parameter. Okay, and now we can go and we can use those standard functors if we want. Or we can use function pointers or functors. Build around that with the function pointer. That will work fine with the function pointer. And also with our user-defined functor. And then of course our lambda will work fine as well. This time it's going to do multiplication. So this is a simple example of where the standard function will come in handy. Again, we are creating an object, passing the particular type. Those will match what we want to pass in, these return int, and they take in those integers.